Welcome to another video on my Raspberry Pi 2 running Ubuntu Linux as well as the Robot operating system. Last time I wanted to use an LDR, light dependent resistor, and that didn't go very well. The point is that for real use of an analog sensor as an LDR, or not really a sensor but an analog device as an LDR, with a digital computer, which the Raspberry Pi actually is, well, digital computer, actually a computer with only digital interfacing. I need a converter. I did not have it the last time and I do not have it now. Can I use it? Yes, I can, but it is not necessarily right. So right now, although I can make a signal completely positive to be measured and completely negative to be measured, that's not a function of an LDR. A light dependent resistor should be measured with its actual value. Before the LDR I used a light dependent transistor, a photo-transistor, this one or something like it, in combination with a light in the form of a lamp or an LED, light emitting diode, like you can see right here. If I can move the wires a bit, a little bit of a green spot here, and if I press it, well, no, I can press it, but it doesn't do anything because ROS isn't. ROS is running, but the nodes are not running. For digital stuff, well, you need a digital sensor, and I still want to try to use it again. In the past, a few episodes, I tried it with an LED and a lamp, and for some reason the results were not rather conclusive, not really conclusive. So what do I want? Well, the Robot operating system is a messaging system, sending messages and receiving signals and messages. So I want to go back to the photo-transistor and see whatever else I can do with it. So first act, removing the LDR and coupling this to this one. Does it make sense? Not really, because there is definitely voltage over it now, or could be, but the point is, a transistor needs to be needs to have a signal. A transistor usually has 3 connections. This one has 2 because of its setup already. So how do I do it? Well, I have to put this once again somehow to the band cable to receive signal. So that is what I'm going to set up again. So the LDR is out of the circuit. The phototransistor is in, but the circuit hasn't been set up yet. So this will go. And then of course the question is, how will it work? Well, let's go once again here. We have to have input 15, and looking here, this is 7, 9, am I correct? Probably so. Input 15 I have to use for this wire anyway. This is even. The this one is in the odd. So 7, 9, 11, 13 and 15, if that is correct, and I doubt that. And it really does matter, because otherwise I don't get any signal back. So 7, 9, 11, 13, 15. Now let me do it something like this. Hopefully it fits, hopefully it works. And then another point is that last time it didn't make much of the signal. Well, maybe there just was too much signal. So if I do just like this, it will already be different and more sensitive to light that I put on it, like this, shining in the hole of this plastic cap. And let's see if that works better. The only thing that I should think of is not straight in here, but I should do it via. So via the transistor. And then there comes a little bit of a problem. Do I have more connectors? I don't think I do. So that will be solved quite easily. I remove this one from this wire. And usually I do it with my left hand, but I'm ambidextrous, so that doesn't really matter. So then this one goes like here. This wire is shorter and will get this part. So then this part gets here. And goes to the signal via the resistor. Will this work? Well, I can only hope. So finally let's start the node. Publisher. Subscriber. And it is already VPass, etc. So No, it is V pass, which means there's no light. So when I will shine on it, what will it become? Is the light bright enough? I would think so. It says V pass. Is it? But this is V pass as well. And what does it say with this? No light is V pass. What does it say with? Now it should say V block. And that obviously it does not. So time for some more thinking, unfortunately. Right. So the output isn't exactly what I expect, and I'm talking about the output in this window. So I have checked once again configuration here, which turns out to be correct. Then I have put the phototransistor with plastic cap on some kind of stable statue, or whatever you call it. Multimeter connected on this side to the ground. And the question is, what are the voltages? Well, first of all, measuring voltage on this side, which is 2 volts more than slightly more than 2 volts. What is it here? 4.5 volts. So if it is here, and now I am measuring actually at about 3.5 volts. It passes there is no light. What is on this side of the resistor is just under 3 volts, as you can see on the multimeter. So here I should take my hand away, then you can see the multimeter. Alright, this alright, so actually it passes the voltage. Now I want it to block the voltage, and therefore I need some light, and I need this to stay connected. So let me shine some light and at the same time keep connected. So I am shining straight into it, but what is the result? And once again I block your view, so let me try to do it this way. It's not really blocking, is it? I am alright, let's measure it like this. And once again shine the light. It should be zero voltage, but that is not happening. So what's wrong? It could be, in theory, that something of the GPIO on the GPIO side is wrong. So let me see. 13 is out, so I could change that. What I also can do is change this value to 17. Yeah, let's do that. Stop this program. Change this value to 17, so that 17 is the reading output of the value. And then go to 17 and here 17. Save and start doing it again. Oh wait, I have to change this from 15 to 17. Hopefully this works out. Let's measure here. Well, this is definitely a pass. Oh wait, this channel is already in use. 17 GPIO in. Wait a second. No. Oh, the channel send is invalid on a Raspberry Pi. That is a very good one. I can't just use any, and I have to check that. Good point, very good point. Because of this error, we can check online where this is the GPIO header details and pinout, and indeed I used 15, but I can also use here 16, 18, 22, 29, etc., except 30 and 34 and 39. Those are grounds. So I am going to use 16. Let's see how that works out. So I have to go here, 9, 11, 13, 15, 16. Let's count. 7, 9, 11. No, I'm doing it wrong. Oops, that one should be here. So 7, 9, 11, 13, 15, 16. Then this should be 16, and this should be 16 now. Save it, run it. Channel send is invalid. Which one is invalid? 13? Oh wait, yeah, right, because I have to change this to 16. That's the whole point now. This should do it. Yes, thank you. Alright. But does it work? Big question. Once again, checking for the coda, it still says pass. And here pass says there's no light. Alright, so let's give it some light. And I think I will do this in another setup. I will turn it around. Then I don't obstruct the multimeter view. So let's measure here. Now it says 1 volt. Is that correct? Well, there is some volts, but it says block. That's odd. Now it says pass. So what's wrong with it? Now it says block. Pass. I press against the resistor and it says block, and I leave it and it says pass. How can that be? That makes no sense. Well, the point is of course that when the signal is 0, it assumes to be light and block. So what if I do here? It says block. I leave it and it says pass. Really? So what happens when I shine light on it? It says block, which it should. So I touch this. And you see that here it says 4.5 volts. And it says there's light. I remove it and it goes back. So here you see difference. Now it says when no light, it says something different than here. Remove the light and you see it go away, and here. So this is interesting, this works. This shows that the phototransistor actually does work. The only thing is why doesn't the software respond accordingly? That's a big question. This shows that my software is not entirely accurate, apparently. Oops. Right, so there's a clear case of some, yeah, how shall I call it? Missing clue. On one hand, I just found that the sensor, the phototransistor, does work because of simple measuring here, shining a light and taking it away, shining a light, taking it away. And yet the output says block and keeps saying block. So once again, block, and it keeps saying block while it clearly should say pass. Okay, what can we do about it? Add another resistor in between? Possibly. let's just do that. Maybe there's something wrong here. Not enough resistance. Alright, let's put this one here. And let's put this one. Same lane and same lane. Come on, cooperate, please. Alright. So let's measure again. Alright, so how much is this? About let's go to resistor setting, resistance. So now I have to look in this scale. For a moment disconnect the mass from here to here. And I would like to have a nice value now. Let's see, I do have no, I don't. Hold on. This is the value. I'm measuring. And I'm measuring again. Alright, that hardly matters. So let me put another resistor in here. Although I can't imagine that is the problem. Alright, once again, between here and here. That says some 80 ohms. And this would be I'm surprised. Alright. Should be different. Maybe I'm doing something wrong. Can very well be. Alright. Go back to voltage measurement. Shine the light. And now it says pass. Block. And pass. Block. And pass. See. So that was a difference anyway. Except that it is the other way around. How can that be? I'm shining a light on it and it says pass. Well, according to the code, light should say block. I'm removing the light. What happens? Well, on the multimeter you can easily see what's going on. Now you see block. Block means there's light on it. Well, I'm sorry, but the light is not shining on it. Now it says pass. No light. That is correct. Is it slow? How slow is it? How long should I wait? Light should say block. I don't see block now. riddles with light and dark. Right, considering the length of the video, I'm going to finalize it. What did I do? Replaced an analog LDR with a digital phototransistor again, but this time in a different situation, blocking it from light, finding that things actually work. And yes, I haven't even tried this this switch. Is the switch working at all? I don't find it working. Where should that switch be anyway? 11. Is it in 11? 7, 9, 11. Yes, it is in 11. And something is not quite alright, I notice. Seven, 9, 11. Yes, it is in the correct place, but it's not doing anything. Alright, never mind for now. The transistor is working. I find that out. Is the software working? Again, not according to my idea. So that has to be checked. So thank you for watching. Again, if you like this video, please, and you haven't subscribed yet, please subscribe. You can also follow me on Twitter and Instagram. Please also see my website for my other projects and for how you can make a small donation to keep everything going. And this is going to be continued, obviously. Bye bye.